Hello, my name is Ghazi Ul-Muhtadi Mollik, and my student ID number is 222-63007. You can see this here. And now I'm here to present my assignment. And in the task one, I was required to create a Word class to store information about each unique word found in the text files. So what I did is, let me bring it up. Should be good. Yeah. So for that, I create a init method for the class that initialized the object, and it takes, as you can see, it takes a word string itself, and inside I store a word string that initialize the frequency as well. It initializes the frequency actually to 1 because I found it once, and initialized neighbors as an empty list because yet I have not found any neighbors. And you can say three getter methods here. Um, they actually return the word frequency and neighbors. Yes, and there's another function which increases the frequency by 1 if I find a duplicate word. Um, this is because I don't want any words to be duplicated. And yes, and there's a yeah, there's a sorting neighbor list, as you can see here. Sorting neighbor list. I implemented the sort neighbors method as required. This uses a custom bubble sort algorithm, as you can see, to sort the neighbors alphabetically. That I did not use any Python built-in sort or sorted function, as you can just see here. And these are the methods that I used for comparisons. And yep, and this one, the final one, this is actually because I wanted, uh, it actually provides a string representation for easy debugging and viewing. You can see that. So I'll just run it. Um, yeah, I did run it. The task two in here, I was to construct a lexicon. Just let me bring it out. Yep, here it is. So here I had to a task two actually involved creating a lexicon and reading data from the text files I had to do. And I choose to use an empty dictionary that is named lexicon dict to actually store the lexicon initially. The keys are the word strings and the values are the word objects. Yes, and it allows this allows very efficient checking if a word has already been there. And yes, the read data, it's a function, as you can see, takes the lexicon, yeah, the read data takes the lexicon dictionary. It has two parameters and a file name. As you can see, a lexicon dictionary and a file name, it takes two parameters. It opens the file, reads line by line. You can see it opens the file and it reads line by line with a loop and splits each line into tokens. Here you go. It's, yeah. And then in every tokens, it actually, yes, it converts it to lowercase and then um, I then iterate through its characters, and then I keep only the alphabetic ones using the join method. You can see the join method and is alpha because it's if it's alpha, if this method is true, then this happens. Yes. Um, and after defining the function, well, then I actually have to clean the word as well, because if the clean word isn't empty, it checks if the word is already a key in lexicon data. If yes, it calls the increment frequency method on the existing word object. If no, it creates a new word object with a cleaned string and adds it to the dictionary, as you can see that. After defining the function, I call it 3 times, once for each input file. You can just see here, I call it 3 times, 3 different input types, yes. And then input files actually. Finally, actually, I convert the dictionary values into a list called lexicon list. This list format is suitable for the sorting algorithms we used. Yes. I mean, we will need this for the sorting algorithms that we will use next time. And then, right, let's run this cell. Although I ran it before, but let's run it again. Yes, you can just see what I said. It's being true. Here we go. Yeah, exactly. And the task 3 is sorting algorithms in profiling. We actually to sort the algorithms and inverted profile as well. As far as I remember, that was the task for me to do. So, yep, here, task 3 actually required implementing 2 sorting algorithms using just my own understanding, not any built-in methods. For example, the sort methods. You just had to use the algorithms and data structures to create the methods. And for the insertion sort, for the first algorithm, you can see I choose the insertion sort. And the function insertion sort takes the list word objects and then it iterates from the second element and then compares the current element with to its left and shifts the element to the right until it finds the correct spot to insert the current element. This sorts the list in place, like alphabetically based on the word strings. Using a comparison method, we defined the word class. Second algorithm, let's first run it. Let's just run. And then in the second algorithm, you can just see it's a hybrid sort method. And then I just have to combine my merge sort and insertion sort. Yes, I defined a hybrid threshold constant to 10. That was set to 10 to constant actually. The hybrid sort function checks the list size. If it's less than or equal to the threshold, it calls the insertion sort function. I just showed this one. It just calls this one. Otherwise, it performs the merge sort step by step recursively, and it splits the list into left and right hops, sorting them into hybrid sort again here. Just let me go a bit down. And then it just merges the um, it just merges the hops, merges the 2 sorted hops back in the correct order next time. Then I'll run these cells to define sorting functions. I already run it, but yeah. Found the sorting. Yeah, it's sort of defined to compare the assignment. We can see that it asks to ask for the time difference in the two sorting functions, the time difference. So I create so um and that's why I just had to uh, build this code from the existing code to actually compare the time difference. Yeah, so let's run it again. Yes, as you can see, there's a huge time difference. The average sort algorithm it's 0.75, and yeah, the hybrid sort is about like 0 point around 1-2 seconds. It's very low. So the hybrid sort is significantly faster, as we can see that it aligns the theoretical advantage of merge sorts of n log n complexity. See, over the insertion sort, which is O of n square, which is the average complexity. And in the task 4, we had to sort our lexicon, and then here it is. Here, like in the task 4, that it asks the user which sorting algorithms to use, all right? And then, yes, where does it? Here's the input that it asks the user which algorithm to choose. And then if the user choose, like the user's choice is converted into integers, and then if the choice is 1, then it runs this part, and if the choice is 2, then it runs this part. So what it does is, I'll run now. Yes. So if I, for example, choose 1, yes. So it uses the sorting with insertion sorts. Yeah, it uses the insertion algorithm. You can just see it works well. And if I run it again, if I choose 2, yeah, it also works well the same way. Yeah, but there's a time complexity. So in the task 5, I had to populate the neighbors. It's about finding and sorting the neighbors for each word. A neighbor has the same length actually, and differs by exactly 1 letter. That is what we call neighbor. The find we define the find neighbors function. The find neighbors function takes the sorted lexicon list. Sorry, as we can see that, and just 1 second. Yes. And then for efficiency, it takes groups of words by their length into the words by length dictionary. This avoids comparing words for different lengths, as you can see. And it then iterates through each length groups. All right, so it iterates through each length group, and then for each word, wait a second, let me mark it because I can see it better. Yes. And then for each word, that is word obj1, as you can see, and it compares it only the subset words in the same group actually. Inside the innermost loop, what we call it compares the two words characters by character. You can see where, yeah. after that, it actually is like it counts difference in the in the in the diff count. First, we actually initialize with the value 0 though, and if the count exceeds 1, it stops comparing those two words. And the count is exactly 1 after checking all characters, their neighbors, all right? And add neighbors is called on both words. Yes, add neighbor is called on both words, word objects to add each other to their respective lists. After finding all potential neighbors for every word, the code iterates through the entire lexicon list the last time. For the last time, for each word object, it calls the word object dot sort neighbors. Word obj dot sort neighbors method. Remember, this method uses the custom bubble sort that we defined inside the word class. Ensures the neighbor lists are sorted alphabetically without any built-in function, for example, the sort or sort. Python built-in methods. And then we actually have to run the cells. Just wait a second. Yes. It finds neighbors and then it sorts them for every order. Yeah. The progress messages like show that it is processing where I did a progress message. Oh, where is it? All right, whatever. Probably I removed it. Anyways, and then in the task 6, where the next work is going to the task 6. Yes, so here, finally task 6 provides the sorted lexicon, like, just here, 1 second. Sorted lexicon, including the frequencies and sorted neighbors, like to the file.outtxt. I defined a file.outtxt, and where is it? Yet, yes, here it goes. It's out.txt. It's not file.outtxt. It's actually outtxt. I'm sorry for that. So but before that, I defined a file outtxt anyways. Where is it? Okay, anyways. Txt, okay. So this is a method called write data, which is in the right mood. You're in the right mood. You can see that. And it actually loops through the lexicon to sort list. Here it is. For each word object, actually, it gets the word string, frequency, and the list of neighbors using the getter method, the getter method that we just talked about earlier in the task 1. It's the same way that it gets the neighbors. And then it uses the f string. Where is it? Yeah, it uses the f string, as you can see the f string here. And then you can see it is actually to format the output exactly as specified. Yes, the assignment, right? Exactly, yeah. And then it writes this line into the file. Then it actually, I'll run this actually. Yeah, it's good. If I writing, it writes the file. If I read it, well, let me clarify something to it. It's in the writing mode. That's why we can't see the file now. If it was in the read mode, I would be able to see the file. I have to write the read mode here to actually, for example, if I do R here, if I do R, it will be on the reading mode, but I'm currently doing the writing mode. That's why I cannot see the file. It just happens. Yeah. That's it, I think. So that is it. I think that is all. It covers the implementation of the tasks provided. Yep. We'll just turn off the. All right. Thank you. Bye.